So just one more thing to do, and that is to add sparks when they get hit. So to do that, I'm going to drop down a geometry. I'm going to call this sparks. And the thing is, we have all the data that we want and need for this from the agents. So I'm going to drop down an object merge. And here I'm going to point to the agents. So like here, out agents. And then I'm immediately going to delete them. I just need the attributes. So I'm going to do an add. And here delete geometry but keep the points. And like so. And then I'm going to drop down an attribute delete. And I'm going to delete everything except hit, because I want to know when the agents are hit. I'm also going to keep the hit position, because I want to know where they're getting hit. And last of all, I'm going to have the hit direction. That was the direction of the raycast, and that we want them to like spray out from the agent. So we have all this, and we can see if I do a spreadsheet that I have only that now. Well, I have some groups too. And then I can drop down a blast, and here I'm just interested in these points when they are getting hit. So if they're not getting hit, I don't want them. So I'm going to set an attribute, and if hit is equal to 0, then I'm just going to blast it and put this point. And now we can see if I go, and I'm going to put on points here so we can see it better. You just get it when they get hit. But the point is at the wrong position, but that's an easy fix. So let's drop down a wrangle, and in this wrangle we are going to set the point position. So P equals to the hit position, which we know is in the right place. So by doing that, you can see suddenly the position is at the right place. We also need a velocity. V equals to the hit direction, and that is everything that we need before we start the actual simulation. So let's drop down a DOP network. I'm going to connect that into here, and in here I'm going to drop down a pop solver. I'm going to drop down a pop source. I'm going to drop down a pop object. I'm going to drop down a gravity and a ground plane. And what else do I need? A merge. So let's connect all these together. So I'm going to connect the pop solver. I'm going to connect the pop object and the pop source and the gravity and the merge here and the ground plane. And then I am going to change the order here. And here for the pop source, I am going to do points. Use first context geometry, which is this one here, of course. And by having that, we should have something already. I'm going to turn off the points here. And we can see now we have points that are bouncing away. Not really what we want. So let's first of all turn off that bounce here. So 0 and 0. And then here I want to have a just born group that we're going to use in a minute. And I'm also going to set this attribute, use inherited velocity. I'm going to set this to add to inherited velocity. And I'm also going to scale the velocity to 4. And then I'm going to have this variance here. So by having that, we have something more interesting. So actually that looks pretty good already. But you will notice one thing that will be a problem with this. That is that it sprays away too far from the agents. So what I'm going to do now is I'm going to scale the velocity a little bit. So some of them can go this far, but I want some of the points to be closer to the agent. I also want to add some extra randomness to it. And I'm going to do that by dropping down a subsolver. So here is a subsolver. And then I'm going to drop down a wrangle. And here in group, I'm going to use this just born group. It's called born. All the particles are in that group just when they get born. And then they are not in that group anymore. So then I can have this wrangle just to do its thing on the first frame when they are born, and then it's not going to happen again. So in that way I can do the velocity, and I'm going to multiply it by itself. I'm going to have a random at ptnum, and this function goes between 0 and 1. So some of them won't have a velocity and some of them will have the old velocity. And then the last thing, I'm going to add the randomness I was talking about. So I'm going to do an attribute randomize, and then I'm going to do this rand orient. It's going to be a vector. I'm going to do this inside sphere, I'm gonna have a cone angle of 30, and then I'm just gonna multiply that here too. So I am going to do this vector and this rand, what did I call it? Rand orient? Rand orient, yes, this rand orient, and like so. So if we look at that now, go up here, hide, oh, I'm not gonna hide it, I'm gonna show all, and I'm also gonna drop down a .io and just point to the .net and the pop object, and then I'm just gonna have a field here. So like so. So if we look at this, we can now see that they are getting hit.